All right, good afternoon, my students. This is Mr. D coming at you with another math instruction video. This is part 2 of 5.1, which is technically called modeling polynomials, but there's a whole bunch of things that are other than modeling polynomials. So this is part 2. In this part, I'm going to be talking about the parts of a polynomial, and also talk about degrees of polynomials. So bear with me for a bit. This is again, the same notes that I've given you before, but this time we're actually going to point this out. And hopefully at the end of this video, I'm going to do some examples of like a chart where it labels the parts of a polynomial, okay? Let's start here with the coefficients. Basically, when you're talking about the coefficients, you've got to remember that they have to be numbers that are in front of a variable. So if there is no variable associated with a number, then there is no coefficient for this, okay? So here, the coefficients really are these two numbers here. This is a +3 and a -2, and this is what I wrote over here, okay? 3 is in front of this x squared, and -2 is in front of this x. So those numbers are the coefficients. Variable, that's pretty easy, okay? It's just asking, hey, what letter are you using in this polynomial? In this case, the variable that you're using is x. And so our answer here for variable is x. The constant, again, that is just a number that's sitting by itself. Okay, it doesn't change. It doesn't have a variable beside it. Okay? Okay, all constants have a degree of 0. Okay, and that's what makes them polynomials. Okay? And finally, and we're talking about degrees, and we're going to talk about degrees a little bit more. But here's some examples already. The degree for 3x squared is 2 because that's the highest exponent for this polynomial. For this term, the highest degree, the degree for this term is 1, and the degree for this constant is 0. Okay? So I hope that's really all there is to parts of a polynomial. So if you don't mind, let's talk about the degrees of polynomials. Okay? All right, here we go. Degrees of polynomials, starting with the monomials. Okay, remember, monomials are polynomials that only have one term. Okay, so here they are, monomial here, here, and here. Talk about the degrees here. With monomials, it's the highest exponent if you have only one variable. In this case, x to the 3, then the degree for this is 3. If you have more than one variable, more than one letters, as in A, B, C, then you add up all their exponents, and that'll be your degree. In this case, it's 2 plus 3 plus 1, invisible 1 here, okay, on the C. So 2 plus 3 plus 1, that is 6. The degree for a constant, or a monomial, okay? Constant is a monomial that has no variable, basically. Degree for that is 0, okay? And we say it's 0 because if it did have a variable, that variable would be x to the 0. Okay? Let's see degrees of other polynomials. It can be binomial or trinomial. Okay? Let's say it's only using one variable. Here it's only using x. Well, you pick the term that has the highest exponent. Here's an exponent of 2, so this is our highest exponent, so our degree is 2. Here, the highest exponent is 5. Versus 7x squared versus no variable or with an exponent. So that x to the 5 is our highest degree. X to the 5 degree is 5. Okay? What if you have polynomials that use more than one variable? Well, here we go. So you pick the term that has the highest sum, or highest, when you add their exponents, the one with the highest addition is the degree for that polynomial. So here is x to the 2, y to the 3, together that's equal to 5. X, y to the 4, this is 1 plus 4 is equal to 5 again. And over here, x, y to the 5, 1 plus 5 will give you 6. So the degree for this is 6. And last example, let's say you have, this is x to the 3, y to the 4, 7x, y to the 3 minus 2xy. Well, you add up the highest exponent. I think this is the highest addition of exponents, 3 plus 4. Degree there for 7. Okay? So, if you missed anything, I guess you could try to pause the video if you want, or rewind the video if you missed anything. But now we're actually going to let's try to do some examples of this that are very similar to some of the questions you're going to get in your assignment. Okay? So let's say I'm going to make a chart here. So I didn't make this ahead of time. Yeah, this is good enough. Okay, so in this, this is our example. Let's say, let's make this one up. Let's say give you an example. Let's say 2x squared minus 5. Okay, so then here I'm going to ask you to write the coefficients. And in this column, I want you to write out the variable that they use, or variables. And here I want you to write the degree. And over here I want you to write the constant, if there is any. Okay, so here's our first example. The coefficient, the only coefficient that I see that's in front of a letter or in front of a variable is this 2. So I'm just going to write positive 2 here. The variable being used is x. The degree for this polynomial is the highest exponent that I see, which is 2. And the constant that I see, remember when you're writing out the constant, it is also including the sign in front of it with it. So minus 5. You also got an example like this from your assignment. Let's say I just put the letter B here. This is letter B. Okay, this is a monomial. This is also a polynomial. This is not 6, this is B. Okay? So what is the coefficient of this monomial B? Well, remember, there's an invisible 1 in front of here. Okay? It's not 0, because if this was 0, 0 times B would be 0. There'd be nothing there. Okay, but instead you have 1B here. But we never say, hey, this is 1B. We just know that there's an invisible 1 in front of there. What's the variable being used? Obviously, it's the letter B. Now, the degree is also invisible. Okay, there's an exponent of 1 here, even though we don't show it, because it's kind of pointless putting a 1 here and a 1 in front of it. It's like I try to tell my students, if your name is Jake, you don't go walking around with a number 1 in front of you and say, hey, I'm 1 Jake. Okay, nobody does that. The constant, in this case, there is none, because I don't see a number standing by itself with this polynomial. Okay, and then finally, let's try this, negative 8. What is the coefficient for this negative 8? Well, it has no coefficient because there is no variable. None. No coefficient, because coefficients are numbers in front of variables. Okay? In this case, there is no variable, so there is no coefficient. So variable, also none. The degree for this is not 1, but it's 0, because if it did have a variable, and I'm not going to put it on it, if it did have a variable, let's say x, that would be it to the exponent 0, because anything to the exponent 0 is equal to 1. And negative 8 times 1 is just negative 8. Constant, well, guess what? This now monomial is now going by another name also. It's a monomial, it's a polynomial, but by itself, it could also be considered as a constant, because that's what constants are. Oops, sorry. Constant is negative 8, because he is a number by himself, so that makes him a constant, right? Because according to our definition of constant, okay, right here, these are numbers that don't change value, numbers that is by itself. Okay, well, looks like this negative 8 is by himself, so he is a constant. Okay, let's try one last one. How about a trinomial this time? How about negative x squared minus plus 3x minus 2? Okay, again, coefficients are numbers in front of variables. So there's an invisible negative 1 in here, so that's 1. There's a plus 3, those are the coefficients, because those are numbers in front of variables. And variables right beside them. Variables being used here is just x. The degree, the highest degree here, the highest exponent is 2. And finally, we have a constant of negative 2 here. Okay, so, oops. Okay, so I do hope that this video does help you a little bit more with your assignment. And if you have any questions, bring it to class. But for now, have a good day.